All right, in this video, we're going to go through an example of 2.3.5, which is to analyze real-world graphs and determine the characteristics. So the first thing we want to do whenever we're given a graph that's in a context is to read it and understand what's going on. So the title says water in reservoir. Reservoir is basically just an area, like a tank, that's containing water. The y-axis says water in 1,000 feet cubed, so that's like the water volume, how much water is actually in the tank. And then on the bottom is time in hours. So the first thing it asks us is the independent variable. So which one's causing the other to change? So if I'm thinking about this, is time causing the water to drop, or is the water dropping causing the time to change? Well, it only really makes sense that time is causing the water to drop, so my independent variable is time. I also know that my independent variable will always be the x-axis. So that means my dependent variable is the water level, and I'm going to put in 1,000 feet cubed. So my next set of questions is talking about like the slope and the y-intercept and what those actually mean. So for slope meaning, we have to actually calculate the slope. For ones like this where it gives us 2 points, I think it would be best to do the slope formula, but you could also count rise over run. Just keep in mind the scale of the graph. So like these are not counting by ones, these are counting by 500s. So I'm going to do it both ways. Let's quick do the rise over run. So if I'm counting the slope, rise over run, well, from this point to this point, I'm rising down 2, but it's really going down 1,000. So I'm going to go negative 1,000 over, I'm running 1, 2, 3, 4, but really, again, we're counting by tens, so that's 40. And if I simplify that, negative 1,000 over 40, that gives me negative 25. If I wanted to do the slope formula, remember slope formula is that y2 minus y1, x2 minus x1. Well, if I label these as x1 and then y1 and then x2 and y2, well, then my slope formula down here would be m equals y2, which is 2,000, minus y1, which is 3,000, over x2, which is 60, minus x1, which is 20. And if I simplify that, again, I get negative 1,000 over 40, which is what I was simplifying earlier up here. And I know that's just negative 25. So either way, whichever method you like better, do it however you like. So my actual slope is negative 25, but I need to figure out what does that mean. Well, I'm going down because it's negative, and I'm going down 25 what? So my rise is the water level. So I'm going to say the water level is decreasing 25,000 feet cubed. So you have to use the variable or the units they give you. So it's decreasing 25,000 feet cubed every what? Every hour. Since it's negative 25 technically over 1, we're going down 25,000 feet cubed every 1 hour. Okay, so I've given the actual slope, the number, as well as explaining it in the context. The water level is decreasing 25,000 feet cubed every hour. My next part is the y-intercept meaning. Well, the y-intercept is where it crosses the y-axis, and so these are counting by 500s. So if I go up one more box from 3,000, that means I'm at 3,500. So for y-intercept meaning, I know that the y-intercept is 3,500, but what is it talking about? 3,500 what? And so the y-axis over here is talking about the water level. So I'm going to say the water level was at 3,500,000 feet cubed. And the y-intercept is like at the start, at the beginning. And if you look down here, the time that has passed at that moment is 0 hours. So I'm going to say at the start. And that's all that you need to know.